Okay, class, today we're going to talk about finding slope from a formula. Okay, so we're still working on this same standard here. It says write an equation in the form of y equals mx plus b to model a linear relationship between two quantities using verbal, numerical, tabular, and graphical representations. Well, we've already dealt with tabular, which is dealing with the table. We've dealt with a graphical representation where we were finding slope from the graph. Well, today we're going to be looking at the numerical. Okay, what if I just give you 2 points and ask you to find slope from that? Okay, so let's kind of review what we have done. Okay, we have done slope from a graph, and we know from a graph we're going to look at rise over run, how much it goes from one point to the next, how far it goes up or down, and then how far it goes right or left. Okay, we've looked at finding slope from a chart where we look at our delta y versus our delta x, okay, or our change in y, the change on the y side divided by the change on the x side. Okay, today what we're going to do is we're going to look at slope with a formula, and the formula is slope equals, because remember the m represents slope, y2 minus y1 divided by x2 minus x1. So let's just kind of review real fast what it is that we know. If I were to give you this graph right here and ask you to find the slope, what we're going to use is rise over run. Okay, so m equals, and what we have to do is we got to pick 2 good points. Okay, well, points are identified here, and we can pick any 2 of these. So I'm going to pick this one right here because you know it's got special significance, being the y-intercept, and this one right here. Okay, so those are the 2 that I'm going to use. So now if we look at this, to go from one point to the next, and typically it's best if you actually go left to right, just like we read a graph. From this point, the left point, to the right point. From here I got to go up 3 and go over 1. So that means our rise is 3 and our run is 1. So our slope is actually 3 over 1. But if we were to write this in the formula, y equals blank x plus blank, this 3 over 1 then simplifies down to 3. But if I ask you to find the slope, slope is always in the form of a fraction. So this is what I'm really looking for. And then if we needed to finish this out with our y-intercept, we'd come over here and we'd find our value whenever that crosses the y-axis, or the point in which it crosses the y-axis, and we look at that point. And I know that this point is going to be 0, -1. So we want the y value when x is 0. So we would have 3x plus -1 for this equation. Well, what if I gave it to you in a t-chart? How do we find slope? Well, this one is our delta y divided by delta x, which means we come and look at our change in y, which is 3, and we look to see if it's consistent, divided by the change in x. So this would be m is equal to the change in y divided by the change in x. And again, we end up with the slope of 3 over 1. Okay. Well, what if I asked you to find it with today's version? And today's version is, what if I give you 2 points? Can you find the slope? So I'm going to pick 2 different points this time. I'm going to pick this point and this point right here. And it doesn't matter which 2 points that you pick as long as the 2 points lie on the same line. Okay. That's the key. They have to lie on the same line. So if you're given a t-chart, all of these points will be expected to be lying on a line, okay, on the stuff we're doing right now. Okay, so here's our point. First, we identify this point, and this point is 1, 2. And this point is, let's see, 2, and then 1, 2, 3, 4, 5. So we picked 2 points. So we've got point 1, comma 2, and point 2, comma 5. Well, in order to use this formula, the first thing we have to do is we got to figure out what is this y1 and y2 and x2 and y and x1, all that kind of stuff. Well, basically all you do with this is you identify your points as this is going to be point number 1, this one's going to be point number 2. Makes no difference which one you call what. Whichever one is 1, the other one is 2. So once you identify that, then this first point becomes x1 and y1. The second point then becomes x2 and y2. And so now we just plug in our values into our formula. So it says y2 minus y1. So m equals, y2 is 5 minus y1 is 2 divided by, well, then it says x2 minus x1. So x2 is 2 and x1 is 1. And now we just do our math. 5 minus 2 is 3. 2 minus 1 is 1. And we still get the slope of 3 over 1, just like in the previous two examples. So that's how we find slope from a formula. So let's see if we can try a couple. So here's our first one. Okay, I've got 2 points that lie on a line. Okay, so the first thing we do is identify the point as point 1 and point 2. And again, like I said, it makes no difference which one you call what. So once I do that, this becomes x1 and y1, and this point becomes x2 and y2. And now we plug into our formula. So we start with y2. So m equals 6 minus y1 is 3 divided by x2 minus x1. Okay, now we do our math. Well, 6 minus 3 is an easy one. We know that that's 3. Okay, but 2 minus negative 5, well, that one's a little bit tougher, so we use our integer rules. Okay, if I'm subtracting and I can't do that, so I change subtraction to addition, next number to its opposite, and now we have 2 plus 5, which is 7. So the slope that goes through, or the slope of the line that goes through these 2 points is 3 over 7. Well, what that basically means, if I were to have a graph, wherever that point happens to be, that's going to mean the slope of 3 over 7 means I'm going to go up 3. So 1, 2, 3 over 7. 1, 2, 3, 4, 5, 6, 7. So up 3 over 7, and I put a point. That's what that slope refers to. So if I did the other direction, that would be down 3. So if this is, let's say that is at point 2 there, or number 2. Okay, I'm going to go down 3, so 1, 2, 3, and over 7. 1, 2, 3, 4, 5, 6, 7. So if that were the case, if my y-intercept was positive 2, that right there would be the line that would have those 2 points. Now, I don't know if that's correct or not, and it's not because of where these points are at, but that would be how you use this slope. All right? So let's try one more, and then we'll see how this is applied on the test. Okay, so here we've got, first thing, we identify our points, and then we identify what's what. So this one is x1, y1, x2, y2. Now once you when you get used to this, then you don't have to actually label those. It makes it very easy. Okay, so this is our y1, so slope is equal to 5 minus, and our y1 is 5, divided by x2 minus x1. So we end up with the slope here. We got 5 minus 5 is 0, and then negative 9 plus negative 8 gives us a negative 17. So our slope is 0 divided by negative 17, which we know will make our slope just 0. Okay, and yes, you can have a slope of 0. So that's how you find slope using only 2 points. Well, how is this applied? Well, here's a question where it's like on the STAR test that you will see. Okay, it says, what are the slope and y-intercept of the graph of the linear function shown on the grid? So they give you 2 points, all right? They give you this point of negative 6, 0. They give you this point of 2, negative 2. Now on the STAR test, they will give you that formula of m equals y2 minus y1 divided by x2 minus x1. That is on our formula chart. Okay, so you need to know that if you're given 2 points, you can use this formula to find slope. So let's see if we can do that. M equals. So I'm going to call this one 1, and I'm going to call this one 2. Okay, so I start off with y2, which is negative 2, minus 0, which is y1, divided by x2 minus x1. Okay, so our slope then is going to be negative 2, what am I doing there? Okay, negative 2 plus 0, or negative 2 minus 0. It's going to be the same either way. You get negative 2. So that tells us we definitely have a negative slope there. And then 2 minus negative 6. Well, 2 plus 6 is 8. So we simplify that, and we end up with negative 1/4. So I look down at my problem, and I find which one has a slope of negative 1/4. And there's my answer. So that's how we find slope using a formula.